Hello guys, and welcome back to another explosive episode on JAMB Chemistry. And of course today we're going to be looking at the preparation of alkenes. All right, preparation of alkenes. All right, and of course, do not forget that this video tutorial is brought to you by the one and only O3 Schools JAMB app. It is all you need to succeed in your exam. All right, if you want to succeed and not succeeds, please go to Play Store right away, download the application, and start practicing your way to a very high JAMB score. You can look into our testimonies on this channel to see how the app has helped thousands of students. Your case can never be different in the name of Jesus. All right, now let us continue. Preparation of alkenes. But before we do that, let us see a question from the O3 School JAMB app. This is a 2002 JAMB question, number 37. It says, the reaction of alkene with hydrogen in the presence of a catalyst. Okay, the reaction of an alkene with hydrogen in the presence of a catalyst is A, an oxidative reaction, B, a nucleophilic reaction, C, an addition reaction, D, a substitution reaction. All right, when we are done with this class, preparation of alkenes, all right, we're going to come back to this question and many more on alkenes from this application, and then we'll answer them together. All right, so the O3 School JAMB app has all you need to succeed. That's all the past questions from JAMB, has wonderful features, has lecture notes for you to study with, and what is more is that we have what the question search feature where you can search for questions according to topics. So you can search for alkenes, questions on the alkenes will come out for you to answer. All right. So we also have the UTME mock challenge that you will conduct for all students that are writing JAMB for this year. You participate, compete with your mates, win a lot of amazing prizes every Saturday. Apart from that, you are getting used to JAMB past questions, you are getting used to JAMB likely exam questions, and of course, you are building yourself. You see your result released every week also. That is the fun of it and the joy of it. Okay, so as you see your result, you're able to work to improve on your previous course, and then you are fully prepared and equipped for the main exam. Let's go to the board. All right, so go to the Play Store and download that application right away. Preparation of alkenes. Okay, so alkenes can be prepared in a lot of ways, all right? And some of them are going to quickly look at just a few of them, maybe 4 or 5, and then we'll go to our nomenclature of alkenes, then before we talk about the reactions that alkenes undergo, all right? So number one of the methods of preparing alkene is hydrogenation of alkynes. Okay, hydrogenation of alkynes. Okay, what you are saying is that once you hydrogenate alkynes, hydrogenation of alkynes means what? Addition of hydrogen. Addition of what? Hydrogen is called the hydrogenation of of alkynes. All right, once you add hydrogen to alkynes, once you hydrogenate them, you're going to have an alkene. All right, so the general formula for the reaction is written below. We know we have not gotten to alkynes yet, but we are going to get there. So just start having the feel of alkynes. No, alkynes have triple bonds. Okay, carbon to carbon, triple bond. The general reaction for the reaction, of course, is if you have CnH₂n minus 2, which is for the alkynes, then if you hydrogenate them by adding hydrogen, when you add hydrogen, you're now going to have an alkene. An alkene with CnH₂n. Simple as ABC. Once you hydrogenate an alkyne, you're going to have an alkene. All right. Also, please, this is related, but not on this topic, but it's good that you take note of it. All right. Once you hydrogenate an alkene, once you hydrogenate this an alkyne now. Once you hydrogenate an alkene now, what you have is an alkane. All right. So that means that if you see hydrogenate this alkene plus H2, what I'm going to have is is an alkane. I'm going to have CnH₂n plus 2. All right. So please take note of that. So once you hydrogenate an alkyne, are going to have an alkene. Once you hydrogenate an alkene, are going to have what? An alkane. Also, once you hydrogenate a triple bond, a carbon-to-carbon triple bond, once you hydrogenate it, all right, hydrogenation, once you hydrogenate what? A carbon-to-carbon triple bond, what we have is that one of the bonds what is broken, okay? We now have what? A carbon-to-carbon double bond. So once you hydrogenate a carbon-to-carbon double bond, also we now have what? A carbon-to-carbon single bond, okay? So once we hydrogenate alkynes, we have alkenes. Once you hydrogenate alkenes, we have what? Alkanes, okay? Please put that at the back of your mind. All right, so this is what the general formula for the reaction of hydrogenation of what? Of alkynes. Of hydrogenation of what? Of alkynes. Let us see an example. Let's say we have an alkyne like C triple bonded to what? To C. The simplest alkyne, which is what? Ethyne, all right? So, of course, we can complete this structure, right? You know, there can only be 4 bonds surrounding a carbon atom. This is 1, 2, 3 already, so you can put one here, H, all right? Then this is all 1, 2, 3 already, you can put here, H. So this is what? An alkyne, all right? So once you what? Hydrogenate what? An alkyne, like what? Ethyne, all right? So plus what now? Plus H2, and I'm going to have what now? I'm going to have what? C, double bonded to what? To C. All right, then of course you complete your structure. All right, this is 1, 2, 3, 4. All right, 1, 2, 3. Then I'm going to have what now? 1, 2, 3. Then I'm going to have 4. 1, 2, 3, 4. 1, 2, 3, 4. All right, so I'm going to have what? 18. All right, so that is what happened once you what? Hydrogenate what? Once you hydrogenate a triple bond, I'm going to have a double bond. This is what? Ethyne. Take note. This is ethyne on its own, and this one is what? Is 18. This one is 18. Okay, all right. So this is how what we hydrogenate what alkynes. Okay, all right. So that's one of the reactions for the what? For the preparation of what? Of alkenes. If you want to prepare an alkene, you hydrogenate what? Alkynes. So let us see another what example. Right? Another, preparation method for what? For alkenes. And number 2, we are going to have the dehydrohalogenation of alkyl halides. All right? Dehydrohalogenation of alkyl halides. Once we dehydrohalogenate alkyl halides, what you have is what? Is alkenes. Okay? In the presence of what? Alcohols. Dehydrohalogenation of alkyl halides. Okay, so once we dehydrohalogenate alkyl halides, all right, what we have is what? Is an alkene. We have what? An alkene, and then we have what? Water also as what? As a product. Okay, let us see the general what formula for this reaction. So if we have what? An alkyl halide like this, like RX. Okay, so this is what an alkyl halide. RX, where R here is what? Is an alkyl. Then X is what? Is an halogen. Okay, so RX, then of course, plus we're talking about the dehydrohalogenation of alkyl halide. So RX now, for example, then plus what? KOH. All right, then you have what? In the presence of what? Alcohol. Okay, what we have? I'm going to have what? ROH, then plus what now? KX, then plus what? Plus H2O. So this is the general formula for this what? Reaction. Okay, ROX plus KOH in the presence of alcohol to give us ROH plus what? KX, then plus what? Plus H2O. All right, so this is what we have. So RO here is what? It's an alkyl. Then X here is what? Is an what? Is an halogen. So for example, let us say that this R is what? Is pentyl. Pentyl, for example, that's what? C5H11. All right, and then let us say this halogen X is what? Let's say it's what? Is Br, bromine. All right, so if it is bromine, okay, what am I going to have? Generally, I'm going to have what now? ROX. That's what now? C5H11. Then X is what? Is Br. All right, then plus what now? KOH. Right, so I'm going to have in the presence of what? Alcohol. All right, C5H11 Br plus KOH. In the presence of alcohol, I'm going to have an alkene, C5H10, then plus what now? KBr plus what? H2O. All right, so this will be what? The equation of the reaction. when an alkyl halides like what pentyl, okay, pentyl bromide, okay, or one bromopentane, okay, or one bromopentane, or what pentyl halides. Okay, let us draw the structure of what of pentyl of this C5H11Br to make it very, very clear for us. So if this is what C1, 2, 3, 4, 5, so that I can know the name of the structure. Okay, bromine is here. All right, then I'm going to have what? Right, this. Okay, the structure is complete. 4 bonds, 4 bonds, 4 bonds, 4 bonds, 4 bonds. All right, so this will be what now? 1 bromo. Okay, 1 bromo. Then what is this now? Pentane. This is what? 1 bromopentane, or can call it what? Pentyl what? Bromide. Okay, anyhow you call it is correct. If you call it what? 1 bromopentane, if you call it pentyl bromide, you are still correct. Okay, so now, so once what this pentyl bromide or 1 bromopentane reacts what with KOH, all right, I'm going to have C5H10, which is what, of course, now pentene, then plus what, potassium bromide, then plus what, plus water. All right, now the degree of what dehydrohalogenation. This part is very, very important. You must take note of that. The degree of dehydrohalogenation of alkyl halides by alcohols is in this order. Okay, 3 degree, greater than 2 degree, greater than 1 degree. The degree of dehydrohalogenation of alkyl halides by alcohol is in this what order? 3 degree alcohol, greater than 2 degree alcohol, greater than 1 degree alcohol. We have not done alcohol yet, but once we get there, we're going to talk about it. All right, but take note of this. That's what 3 degree alcohols are called tertiary alcohols. 2 degree alcohols are called secondary alcohols, while 1 degree alcohols are called what? Primary alcohols. This means that what? That a 3 degree alcohol, which is of course a tertiary alcohol, will easily what? Dehydrohalogenate an alkyl halide than a 2 degree alcohol, which is a secondary alcohol, and also which in turn will what? Easily what? Dehydrohalogenate an alkyl halide more than a primary alcohol. You get me now? All right, so we have 3 degree alcohol, we have 2 degree alcohol, we have what? 1 degree alcohol. All right, tertiary alcohols, which are 3 degree alcohols, will easily dehydrohalogenate alkyl halide more than 2 degree alcohols and more than what? 1 degree alcohol. So this is the order. You might need to what? Take note of what of this, because you will see it in your exam. All right, so please take note of that. All right, so now having seen that, we can now go to what? Another what? Method of what? Of preparing what? An alkene. Okay, let us see the third method. Okay, this is number 2. Please take note. This is number 2. Number 1 we say is the hydrogenation of alkynes, which we have looked at. Number 2 we say the hydrohalogenation of alkyl halides. All right, and then number 3, let's look at dehydration of alcohols as another method for what? For preparation of what? Of alkenes. Dehydration of alcohols. Number 3, dehydration of alcohols. Okay, so once you dehydrate alcohols, that is, you remove water, okay, from what? For alcohols, all right, what happens is that what? We get what? An alkene. All right, we get what? An alkene. All right, so what do we use to dehydrate this alcohol? We use what? Acid. Okay, so once we dehydrate alcohols using acid, we're going to have what? An alkene plus what? Plus water as what? As the product. All right, let's quickly see a reaction. The general formula for the reaction, if you have an alcohol like this, C, let's say OH, all right, then of course, in the presence of what? Of an acid, then we are going to have what? An alkene, C. Okay, alkene is what? Double bond, then plus what? Plus H2O. Very simple as ABC, all right? So once you dehydrate an alcohol using acid, okay, I'm going to have what? An alkene, then plus what? Plus water. If you see here, I did not complete this structure. Okay, this is the general formula for the what? For the reaction. All right, general what? Formula for the reaction. All right, if I were to now what? Complete what? This structure, let us do that. I'm going to have what now? C. This is what? OH. You know that what? There have to be 4 bonds surrounding this carbon atom. 1, 2. You follow when we did nomenclature of alkenes. All right, so if you know you were not in that class, leave this class now and go and listen to that class first before coming back here. Of course, that's how some of you miss important details. All right, so I'm going to have what? 1, 2, 3, 4 also. So this is what now? Ethanol, all right? An alcohol with 2 carbon atoms is ethanol. Okay, this is ethanol. Okay, so once what? Dehydrate this using what? Acid. Okay, we're going to, of course, have an alkene having 2 carbon atoms, which will be what now? Ethene, all right? C2. All right, I can complete the structure. 1, 2, 1, 2, 1, 2. Okay, I'm going to have what? Ethene, then plus what now? Plus H2O. All right, so that is that for that. Okay, so now this is ethene. So this is how we can also prepare what? And what? An alkene. When we dehydrate what? Alcohols. Okay? Once we dehydrate alcohols using what? Acid. Let me add this. Using acid. Using acids. Okay? What we have is what? Is an ethene. So it's an alkene plus water. That's the third method. Please, before we go to the fourth method, if you have not liked this video, that thing you are doing is wrong. Please click on that like button because it will make other students easily find this video. All right. If you have not subscribed to this channel, that thing you are doing is evil. All right. Because you are learning and you do not want other people to learn and you do not want this channel to grow. So please click on that red subscribe button if you have not done that. But if you have done that before, thank you so very much. And do not forget to share. Share to your WhatsApp group, share to your Facebook group, share to your all your social networks, to your friends, to your class group on WhatsApp. All right. And of course, let others learn, let them succeed. All right. Now let us go to another method. The fourth method we are going to consider for the preparation of alkenes is dehalogenation of vicinal dihalides. Okay. Dehalogenation of vicinal dihalides. Number 4. Number 4. Dehalogenation of vicinal dihalides. Okay, let the word vicinal, they're not going to what confuse you. Okay, so this is what very, very easy. All right, so we say to what? To prepare what? An alkene, we what? We dehalogenate what? Vicinal dihalides. Okay, let us see the general formula for this reaction. Okay, so for this reaction, this is it. I'm going to have C, then X, then X. Okay, it's having what? 2 halogens. That's why you are seeing what? Dihalide. Okay, that's why you are seeing dihalide. So this now dehalogenation plus in the presence of what? Presence of zinc. In the presence of zinc, I'm going to have what now? An alkene. Okay, I'm going to have an alkene. Depending on what number of carbon atoms here, that's what we are going to form here also. All right. So now let us say I'm going to have an alkene, the plus zinc what? Plus zinc X, Z and X2. Okay, these two what? Halogens will now what? Combine with what? With the zinc in the what? In the product side. All right, so this is how we can prepare what? An alkene. Another method for preparation of what? Of an alkene. Okay, we call it what? Dehalogenation of vicinal dihalide. That means we are removing these halogens from this dihalide. All right, and then we are now getting what? An alkene. All right, so now let us see an example. Let's say we have the simplest what? Dihalide. Let's say we have what? And dihalide what? With 2 carbon atom X. Let us complete the structure. This is H. This is H. This is what? H. This is what? H. All right. This is complete, right? Then plus what now? Plus zinc. Then I'm going to have what now? What I'm going to have? Let's say this X is what? Is Br. This X is what? Is bromine. The halogen. If X is what? Is Br. All right. The halogen. If the halogen is bromine, then what I'm going to put there is what? In place of S, we put Br. In place of X, we put what? Br. All right. I'm sure you are seeing this right. Okay, so now let us continue. So once we have this plus zinc, we're going to have what now? An alkene. All right, we can complete the structure. This is what? Ethene. Then plus what? ZnBr2. Very simple. Okay, this is very, very, very what? Easy. This is called what now? This is called 1,2-dibromo. What now? Ethane. The same thing. Okay, 1,2-dibromoethane. Okay, so now this is how what we prepare what? An alkene. But what about if we have what? Let's say we have what? A dihalide. Okay, with 4 carbon atoms. For example, let us see another example. Let us not use what? The simplest what? Dihalide. Let us use a dihalide that has 4 carbon atoms. For example, if we have C, then here is what? Br. Then here is what? Is Br. Okay, so if you have something like this, then plus what now? Zn, and we're going to have our product. Our product now will be what now? Going to have a alkene with what? With 4 carbon atoms. But where would the double bond be? All right. When it was 2 carbon atoms, it was easy for us to place what the double bond there. We know that the double bond will be in between the 2 carbon atoms. But here, there are 4 carbon atoms. So where are we going to place the double bond? So it's very, very easy. What I'm just simply going to do is what? Place the double bond in between the 2 halogens. Okay? Place the double bond in between these 2 halogens. All right, so that double bond will be somewhere here. So if you want to have your product, you're going to have your C double bonded to what? Okay? You're going to have your C, then your C, double bonded to what? To C, then C. Then plus what now? ZnBr2. ZnBr2. Very simple as A, B, C. So do not be scared about anything. It's very, very, very easy actually. So the halogenation of vicinal dihalides is another method for preparing alkenes. So let us see the last method that we're going to consider for preparing what? Alkenes. It will be called what? That method is called reduction of alkynes. Reduction of alkynes. So once we reduce alkynes, depending on the catalyst that we have, we're going to have what? A cis or what? A trans structure. Okay, once we reduce an alkyne, depending on the what? On the catalyst that we use, are going to have what? Either what? A cis structure or what? A trans structure. Let us see an example. So number 5, I say is what? Reduction of what? Of alkynes. All right, let us see the general formula for the reaction. Let's say we have what? Have an alkyne like this, arrow. Okay, C should be bonded to what? To C. Then I'm going to have arrow, this an alkyne. All right, let's say depending on the catalyst we use, and like I said before, depending on the catalyst we use, I'm going to either have a cis alkene or a trans alkene. All right, so if I've not done, follow us in the nomenclature of what? Of alkenes. You may be confused when I talk about cis and trans. Okay, but of course we did that in geometric or isomerism, but we did not actually teach. I did not actually teach you how to what? Name it at that point. But if you join the nomenclature of what? Of alkenes, you will know and understand how to name what? Cis and trans structures. Okay, now let us go. We're going to have what? Arrow C, depending on the catalyst. So if you use hydrogen or lead, hydrogen and lead, or you use nickel and what? And boron, that is one catalyst. Then number 2, if you use sodium, or you now use what? Lithium and what? Ammonium. Okay, these are the what? The 2 catalysts. Either you use H2 and what? And Pb, or use nickel and boron, or use sodium, or use what? Lithium and what? And ammonium. So if you use this catalyst, this H2/Pb or Ni and what? And boron, that is nickel and boron. What I'm going to have? I'm going to have a cis structure. So I'm going to have what now? C double bonded to C. I'm going to have R, arrow here, H. Okay, this is what I'm going to have. So I'm going to have a cis structure once you use any of these catalysts. But if you use this catalyst, I'm going to have a trans structure. You know how a trans structure looks like already, right? So I'm going to have what? This here will now be what now? R, here will be arrow, here will be what? H. What? H. Okay, so it's as simple as A, B, C. So take note of that. So now, once you reduce alkynes, depending on the catalyst, I'm going to either have a cis alkene or a trans alkene. This is what? This is trans. This is trans. This one is what? Is cis. S-I-S. C-I-S rather. Cis. All right, now, let us take an example to what? To bring this point further home. All right, so if, for example, if we have what? An alkyne. We have an alkyne like this. Okay, we have CH3, C triple bonded to what? C. Then I have C2H5. Let's say we have what? An alkyne like this. All right, and then in the presence of what? Of a catalyst. Let's say we use what? H2 or what? Pb. Okay, so if you either use H2 or Pb, or what other one can we use? Nickel or boron. Okay, so if you use H2 and Pb, or we use nickel and boron, okay, we're going to have what? A cis structure. Okay, so now that means we're going to have what? Cis structure. C, the bonnet to what? To C. Then of course, here, just carry this one, put here. CH3. Then carry this one, put here. C2H5. Then what will now be here? Here will be H, here will be what? H. So this is what the product. Very, very, very easy. No need to stress yourself. All right. So once we have what our alkyne, all right, to form the cis or the trans structure is very easy. Carry the group that is here, the alkyl group that is here, place it on top of here. Carry the water alkyl group that is here, place it on top of here. All right. So this will be very, very easy. So we can name the structure. All right. Let us name the structure. What structure would that be? This is what a trans structure. That means we are naming like this. All right, this is what concerns us here. First of all, how many carbon atoms are in the what? In the parent chain? 1, 2, 3, 4, 5. Okay, we already know it's a what? It's a pentene. Abi? Now, what is the location of the double bond? The closest location to this double bond is what? 1, this is 2. All right, that is what we're counting. We have to count from what? From left to right. If you count from right to left, I'm going to have 1, 2, 3 before the double bond. All right, so I'm going to have what? 6 pent 2 in, okay, 6.2 Na or 6.2 in. All right, it's as simple as ABC. Okay, so now we have gotten what our cis was structure. We have named it. All right, now let us see if you use what another catalyst. Let's say let me use another group. Let's say you have C4H9. Okay, bonded to C, bonded to what? To C, and I have what? C3H7, for example. All right. So let's say we have this now. Okay, as what? As our alkyne. All right. And then in this other example, we now use what another catalyst. Let's say we now use what? Sodium, or we use what? Lithium or ammonium. Okay, we know that we're going to have what? A trans structure. So our structure will now be what? C. All right. So this side, this will be H. This will be what? H. Then here will be what now? Carry this group, put here. We're going to have C4H9. This first group, put it on this right. Then the second group, put it on the other side. C3H7. Okay, if you want to name the structure, what do we do? It's as simple as ABC. Let us go. This is 4. Okay, 4, 5, 6, 7, 8, 9. That is what? A nonene. Okay, a nonene. All right, we already know that is what? It's nonene, okay, or nonene, all right, because that's an alkene. All right, so now let us see the position of what? Of the double bond, or the double bond. The closest position of the double bond, okay, now we are naming what? A trans structure. That means if I'm naming, we are going to consider just this direction, okay? So now let us consider, this is what? A nonene. Then the closest position to what? To the double bond there is what? Is, we start from what? From this left to the right. This is 4, this is 5. Okay, you will not understand what you are doing if you have not followed us on the nomenclature of alkenes. So do not waste your time. If you have not watched that class, go back, watch the nomenclature of alkenes, then come back. You understand what you are doing here. All right, this is easy. So now let us do that. 4, this is what? 5. All right, 5. This is what now? 6. This is what? Plus 3 is what? Is 9. That's how I have on nonene. But then now the position of the double bond, the closest position, this will be 4, this will be 5 before we now get double bond. But this will be what? 3, this will be 4 before we get double bond. That is what? 4, which is 4 we are going to what? 4 is shorter than what? Than 5. So we are going to have trans what now? Is it pent? Is it nonene? Trans what? Trans non. What now? How many in? 4 in. Okay, this one is the position of what? Of the bond. All right, so we're going to have trans non 4 in. All right, so now this is very, very easy. But the important thing here, okay, is what? Is to know that what? The catalyst that we use depend on what? On what the product will be. Okay, that's what gives us, or that's what lets us know whether we're going to have a trans structure or a cis structure. So these are what some of the ways you can prepare what? Alkenes. All right, in the next class I'm going to talk about the reaction of alkenes. All right, but before that, let us go to the question from the application, and then they do justice to each. They say what? The reaction of alkene 2002 37. The reaction of alkene with hydrogen in the presence of a catalyst is obviously it's an addition reaction, because that is what? Hydrogenation. Okay, so we have what? Addition of what? Of hydrogen. All right, so it's what? An addition reaction, and alkenes are favored by addition reactions. All right, so there are so many questions on the app. Go to the app, search for alkenes, answer all the questions under it, and what, build your confidence towards the main exam. My name remains Master T, your Grand Commander. All right, I would like to see you in the next episode where we'll talk about reaction of alkenes. Thank you for watching.